I'm Keith. This is the PCB Cynic. If you've ever done high speed PCB design, you've definitely heard of three terms: microstrip, stripline, and coplanar waveguide. At first glance, they all just look like a single trace. But when it comes to radiation loss, debugging difficulty, and application scenarios, they're completely different. So here's the question: which one should you choose? Today, we're going to clear it all up in one go. First, let's take a look. The microstrip is located just below the top layer of the PCB and only has one complete reference plane, so a double layer PCB is enough. A certain portion of the electric field is distributed through the air, and another part of it is contained within the dielectric material. Its biggest advantages are low cost, easy debugging, and convenient modifications. So, that's why most antenna traces, LoRa modules, and Wi Fi modules will prioritize using microstrip lines. But its drawbacks are also pretty obvious. Because the electric field is exposed to the air, it radiates more and is more easily affected by surrounding components in the environment. Simply put, it's the easiest to debug, but not the quietest. Next, let's take a look at Stripline. It's sandwiched inside the PCD with complete reference ground planes both above and below. Reference ground planes, the electric field is almost completely confined within the layer, so it has the best shielding capability. It has the lowest radiation and the most stable high frequency performance. That's also why many high speed digital circuits, industrial products, and even aerospace equipment use stripline structures. Of course, the trade offs are obvious. It's not easy to debug, and once the board is made, it's almost impossible to modify. Plus, the layer count is higher. You can see that it's at least 4 layers or more for these PCBs. To sum it up simply, it's the most stable but the hardest to debug. Finally, let's take a look at the coplanar waveguide. Its biggest feature is that the signal line is flanked on both sides. Ground lines are placed directly next to it, and they're on the same plane as the signal line. These ground lines can further confine the electric field and reduce radiation. Compared to microstrip lines, it's even more stable. Compared to Stripline, it's also easier to debug and modify, which is why more and more Wi Fi, Bluetooth, and 5G modules now prefer to use coplanar waveguides. To sum it up in one sentence, it's the most common solution in modern high frequency video circuits. Now, let's take a look at how the electric field distribution compares. If you just look at the electric field distribution, the answer is actually pretty obvious. Microstrip lines are the most exposed because part of them is in the air. Stripe line electric fields are the most confined, since they're restricted inside the PCB by the complete planes above and below. As for the one in between, because it has ground planes on both sides, the electric field strength in the air is greatly limited. That's also why microstrip lines have higher radiation. Stripe line has the lowest radiation, while coplanar waveguide strikes a balance between performance and practicality in many cases. What really matters isn't the trace itself, but what you're willing to accept. If I were to sum it up in a table, then microstrip line, well, it's basically this. It has the lowest cost and is the easiest to debug. As for Stripline, it offers the best shielding and the highest stability. What about coplanar waveguide? It has the most balanced overall performance without any particularly obvious weaknesses. But at the same time, it never quite reaches the very top level in any area. So a lot of salespeople will ask, which one is actually the best choice? Actually, it's very simple. There's no best, only the solution that best fits your current needs. High level design is always about finding a balance between cost and manufacturability. Today, you just need to remember three things. First, microstrip. Microstrip lines are cheap, common, and the easiest to debug. Second, Stripline offers the strongest shielding and the lowest radiation. It's also the most stable. Third, coplanar waveguide offers the most balanced performance, and it's also the most common choice in modern PCB design. Next time you see these three structures, you won't just know their names, you'll truly understand when to use each one and why. Thanks everyone for watching.